Folks, I just wanted to share with you a template here. It includes some basic GitHub Actions workflows and some Terraform config, in this case pushing the Terraform infrastructure into Azure. But you could utilize it for whatever cloud provider you want, folks, and cater it to your needs. You may have seen me utilizing a repository in some of my recent videos, and I just wanted to give you this here. I'll share the link in the comments so you can use it for your own needs, folks. It's by no means a be-all end-all of how continuous integration, continuous delivery pipeline works. There is always more than one way to skin a cat, like I say, and always put security first and foremost in doing any of your development, folks. Okay, I have included heavily a lot of links in this readme file, folks, and the first one, like I said, security, shifting security left is the first one and probably the most important one, folks, to get right from the start, all right, as early as possible in your software development lifecycle. There's other comments here, folks, about setting everything up to get the repository working. There is a mention of OIDC, OpenID Connect, setting up that trusted relationship between GitHub Actions and the Azure app registration. If you want a video on how to set that up, there is a section of a previous video to do with setting up a Slack chatbot that I released, and there's a full talkthrough in there of how to do that. I'm just basically giving you a high-level overview of what this repository contains, and you can dive down these little research rabbit holes via these links, folks, and learn more about each part of the repository, and from that you can spin off and add more to this repository if you like. And if you want, you can throw in a pull request and we can add to it. There's a license file chucked in there. The get-ignore file, it gets automatically created for you when you create the repository in GitHub, folks, and then you can pull that down. You can add to this as you need. I just took the default settings in here, but if you had files that you did not want to push up, for example, like Docker files, Terraform TFR files, to name a few, folks, then you want to be including them in this here so that they do not get released. Infrastructure, folks, I've set up a basic parent directory from the top down. TFR's files contains a couple of hard-coded values. There's no sensitive values in this case, folks, and they're passed down through the variables into the parent.tf file, folks, and then there's a module call done to pass these variables into. In this case, we're creating a resource group. I've put in a main file as well here, and this here contains the provider versions, folks, and it's important that you put values in for these, and in my case I've put them in here and locked them in as versions for the Azure resource and Azure Active Directory. And if you don't, folks, and breaking changes get released, it will break your workflows, and then you have to go in and start debugging. So lock those in. I found out that to my detriment recently, so I have the required version for Terraform here does say greater than or equals to, but I do lock the version into 1.9.8 in my GitHub Actions workflow. There's a backend setup here in the README file. There's a little section here that talks about the Azure backend, and the Azure provider will include details about setting that backend up in this link here. Set that backend up first before you run anything, folks. It's a chicken and egg scenario. This here must exist before the config is run, otherwise it'll not have anywhere to store the state file when you push it through the workflow. Okay, the only thing you don't need to set up is the Terraform.tf state. That will get automatically created. This is just a key value we give it here. You could call this anything, call it your own name, .tf state. Terraform will recognize that and name that key as per. So I have these already set up in my Azure portal, folks. So there's a resource in there called Terraform. We can look at it here, and that's it there. Okay, and that contains the containers for my state file. And down the bottom here, folks, we can see we're utilizing the OIDC. We set that to true. There's a multitude of features that you can set for these here providers, folks, also provider registrations. You could dive down a rabbit hole for all of these things I'm speaking about, folks. So if you've got any questions, please drop them in the comment. Azure resource provider registrations. There's some of these provider registrations get registered by default. There's other ones that we can register ourselves. It's set to none here to prevent providers getting registered automatically, because it can open up vulnerabilities, folks, if these providers are registered and then people are able to go in and create resources. It could break a lot of things and cause a lot of issues. So it's set to none here, and then it's controlled. If we need to bake in lists of providers that we want to register and versions of those providers, again, it's another rabbit hole of research in itself, folks. It will be, controlled, at a really restrictive level, at an organizational level, folks. I stuck in a data.tf file there, folks. You don't have to put anything in here. It's just a placeholder. There are other examples of other files, outputs.tf as well, Terraform files. You can go in and research these on the Terraform HashiCorp website and find out what they're used for. Again, another rabbit hole of research in themselves, folks. So that's the parent directory, and then the modules. When you modularize your code, folks, keeps repetition down. It's the dry principle. Don't repeat yourself. So this module can be used over and over again. So it can, folks. In this case, we've just got one module, and like I said, it's creating a resource group. The variables are passed down through into the variables file here, folks, and then into the module resource that's getting created itself. What I have also put in here, folks, is a little test resource, and it's got a severity of critical here, and I've put as a highlight, do not deploy this here. So when this is ran through the plan, when this GitHub Actions workflow plan on pull runs, it'll detect this critical resource when it's uncommented. At the minute it's commented out, so it won't do anything. You can uncomment it and actually run it. But I'm keeping it commented out here because I was just using it for testing of this repository, folks. So just bear that in mind, that you don't want to be pushing any resources with critical severities on them, and the workflows, as you'll see in a little bit, will flag these up, and it'll prevent this from happening anyway. But you want to, as early as possible, like I said, in the software development lifecycle, even on the local here, picking up these vulnerabilities and not even pushing them through the workflow, folks. So you can have things set up locally. You could run tools like tfsec, tflint, Terraform format, Terraform validate locally here on command line, and get these faults ironed out as early as possible. Okay, I've put in there a little hashtag needs to be globally unique. So if this here doesn't work for this resource name, folks, it means someone else in the global Azure network has deployed it with that same name, and it just needs to be changed into the workflows here, folks. And we've got a template, basic one. You can cater this to your needs, change it exactly how you need it, folks, and get as much information in these pull requests as you can, because it helps other people when they follow up and they need to develop on this repository. As much a good documentation journey as it is a technical journey, folks, when you're working in tech, there's still good documentation as a support there for the things that you do. Little checkboxes as well to check off that'll show up in GitHub as a little box with an X in it to say that you've done each of these steps. It's quite handy. In this case, I utilized this before for deploying a Slack bot, folks. So there's a little link there to the the Slack thread in Slack. If you're operating with Jira to handle your sprints, you can have like a link to your sprint that mirrors this here work that you're doing. I've got the Terraform Rego file in here. You've probably heard me speak about it on previous videos, folks. At this stage, I've just got the resource group in here, and as it says in the tin, it'll give you a score of 15, 7 and 3 accordingly based on what these steps are: delete, create or modify, and a blast radius of 200. So if it reaches over 200, it's going to break the workflow, and you'll have to go in and investigate. If it's under 200, it'll still show you a readout of what's happening with regards to a score. So if you're creating it and it says 7, okay, I need to go in and possibly look at what's getting created here and get some more eyes on it. If it's deleting it, then you definitely want to get more eyes on it, because it's the worst case scenario. You're deleting things. You don't want to break anything for anyone else. So the GitHub Actions workflows, folks, at a high level, exactly what it says in the tin here. When you run a plan on a pull request, folks, then it's going to run this here action. It's going to trigger this workflow. So it is, and it's called an Azure plan workflow. I've heavily commented it to explain each step in it to help you guys out. The very top one will take you to GitHub Actions, and you can find out all these other links in there. I've just put them in for ease of use, so you can jump to each one as it relates to each part of this workflow. This here obviously is the trigger. the pull request, and it's a pull request to the branch main. So any feature branch, in this case, I'm working off the feature branch with a 002 in the end. If I do a pull request from that into the main branch, then this workflow will get triggered, folks. The next one is setting up the OIDC. Again, remember the Slackbot video that I spoke about. There's a video to walk you through setting this up. There's a couple of little permissions in here in relation to that, and there's also a permission there for pull request write. That's part of the GitHub token down here, and there's a link to setting that up, folks. So it allows you to it allows the workflow to make comments on the actual pull request output. So in this case, if there's a security issue, this part of the job, the static analysis one, will push the comment on what the vulnerability is to the pull request readout. The global environment variables are set up here. There's also a part of the Slack chatbot video to show you how to set those up as well, folks. And there's links here too to show you how to set those up as well. And in this case, they're Azure related. So the static analysis job, folks, you can have multiple jobs in these workflows. I've got two in this case. Static analysis one, shifting the security left. So it's checking for security issues first, and then it will do the Terraform plan if the security issues pass. If they don't pass, this workflow will stop, folks, and it'll show you the errors that have happened or the vulnerabilities, severities that you need to fix. Okay, I've set up the TF-SEC here. It'll check for security vulnerabilities, folks, or configurations that you haven't set up correctly, and they've got severities based on like low, medium, high, critical. In this case, I've set it up to check for critical ones, and like I said in the infrastructure module, folks, this here severity of critical on this Azure storage account is going to flag up when that workflow runs. It was just set there as an example, so I just wanted you to be able to use that and trigger a critical vulnerability. This is a GitHub action, it's checking out the code. This is another GitHub action, it's checking out this TF-SEC pull request commenter action. Okay, this is at an end of life, folks, and there's actually an issue. That little link will explain more about that issue, and it's not getting updated. Whether they do in the future is another thing, folks. You can check on the GitHub Actions marketplace for other tools. They're constantly being released, a multitude of free, and there's also paid versions on there as well of things. All right, it's a bit of a rabbit hole of research again. You probably noticed, folks, there on the GitHub Actions runner, it's the operating system here is Ubuntu. I've locked in a version. There's a lot of versions you should lock into. Again, with like the Terraform providers, Azure providers, you're trying to prevent breaking changes until you actually test them, folks, yourself before they get released to your production environment to see if there's any like breaking changes that's going to break things. So when you lock in a version, it prevents that from happening until you can actually go and investigate them and then set up a process of updating to new versions in your organization, where you can investigate and test those and get other people to approve them. I've set up again Terraform version 1.9.8, like I said earlier, and the OPA agent. It's the latest version. There was a breaking change, for example, recently, just over Christmas, December 2024. It's a game of constantly watching for new updates, folks. It's a good thing when things are updated because there's still people active and supporting them, because when they finish being updated and it's an end of life, it's when vulnerabilities can creep in, folks, and then you're not getting those patched by getting these updates. So when we talk about this end of life for the pull request commenter, just bear that in mind, that this needs to be removed possibly in the future and replaced with something more secure, folks. Even though it's a security checker in itself, these things can become vulnerable too. So that's the end of this plan workflow, folks. It takes it as far as the plan output, and you will then be able to act on that and submit that pull request, get people to review it, and then if it gets submitted, it'll go to this apply workflow, and then the actual resource will get pushed into Azure, folks. In this case, I've already ran it and it's done. And in this case, we can just jump over to here and we can see this was the template resource group, folks, that we were creating. This is where it got created here, and the value was back in the TFRs file, template resource group. Okay, as simple as that. Very simple, high level one, folks. That's it in there. There's also in the actual workflows a destroy one. It's a manual one. So workflow dispatch means that we trigger it manually, folks. It's not going to be triggered automatically and do something disastrous like break all your infrastructure, destroy someone's good work. So that's what it creates, folks, this resource group. And this is the actual repository in itself. Like I said, you can clone this down. Just come to here. There's the code link. Copy it there. And inside, like I said, the README file, it shows you at the start how to clone it down and run it locally even. So git clone, then that URL in there. So if I come back really quickly to one here that did flag up a vulnerability, in this case, one of these here, you'll see exactly what the output will be from that TF sec. So this is what it looks like here. You can see it's outdated because I've scrubbed this storage account from the infrastructure. So I've applied it without actually committing this, because you can see the critical vulnerability that needs fixed. And until that's fixed, then this here would keep flagging up and prevent you from running the workflow, which is exactly what shift left security should do, folks. Prevent you from actually pushing these here to Azure tenant, especially production. That's it at a high level, folks. If you've got any questions, by all means, drop them in. And like I said, I'll share this here repository with you and you can cater it to your needs. I'll leave this one with you as always, folks. I wish you all the best. Take care and good luck.